Now, instead of talking investments and annuities and savings where interest is a good thing, we're going to look at some everyday life examples where when interest accumulates, it means unfortunately more money out of our pocket because we're talking debt. And we have another big formula, but as we saw in previous questions, these really aren't so bad. It's just a matter, honestly, of just getting the hang of how to type it into the graphing calculator. So section 8.6 is all about cars. It says to compute the monthly principal and interest payment on a car. And by the way, this is the same exact formula that they use to compute your principal and interest payment for a mortgage on a house if you're a homeowner. And it's also the same exact formula they use to compute your monthly student loan payment, etc. So it's a very commonly used formula. And below, PMT stands for payment. That's the regular payment amount. Typically, it's a monthly payment, but it doesn't have to be. But for most of the examples in everyday life and on the home market, it tends to be a monthly payment. Equals P is going to be the principal, which in the context of these questions is the amount you're borrowing. So what's the total amount you're borrowing for the car, to buy the car? What's the total amount you're borrowing to buy the house, etc.? R is still the interest rate. N is still the number of times, but instead of compounded, N is going to be the number of times that you make a payment per year. So N equals number, I'll abbreviate number with hashtag, number of times paid per year. And since most of your examples, if not all, on the homework and on the test are going to say monthly payment, most of the time in this formula anyway, N is going to equal 12. Because if you're making a monthly payment, since obviously there are 12 months in a year, you're going to be making 12 payments per year. And then T is still the time in years. Whoop, there's a little T here in the exponent hanging on the side. So T equals time still in years. So how many years are you borrowing the money and paying it back? Okay, so keeping that in mind, looking at example 1 says, suppose that you decide to borrow $15,000 for a new car. You can select one of the following loans, each requiring regular monthly payments. I already know N is going to equal 12 because they're monthly payments. So your first option is installment loan A, and this is a 4-year loan at 8% interest. Your other choice is installment loan B, 6-year loan, so you have more time to pay back the money you've borrowed. However, look at what happens to the interest rate. They say, okay, we'll give you a couple more years, but we're going to bump up the amount of interest we charge you to 10%. So let's start with part A. Part A says to find the monthly payments and then the total interest for just loan A for starters. So monthly payments, we're going to use our new formula. So monthly I'll put PMT to abbreviate payment equals time to use our formula. Again, for now, we're just looking at installment loan A. The principal, the amount we're borrowing, is $15,000 for that car. So $15,000 gets plugged into P times the rate, the interest rate for loan A is 8%. When you convert that to a decimal, move the decimal point 2 hops to the left, you should be getting 0.08 for R. All over, N is 12 because we're making 12 payments per year since this is all monthly payment. Divided by, we got a lot going on in the denominator of that formula. Parentheses, bracket means parenthesis. So bracket, bring down the 1 minus, I'm looking at this denominator up here. Another left parenthesis, 1 plus, R over N. So again, R was 0.08 over N is still 12. Close the parentheses. negative, yep, the exponent's always negative in this formula. Please be aware. So don't forget that negative symbol. N times t is still the exponent. So n was 12 again. Times the time in years for loan A. Well, you have a 4-year loan. So t equals 4 for this loan anyway. Close the bracket. So now we're going to plug this whole thing into the calculator. And I'm going to do the exponent first, just like before. Before I put that whole thing into the calculator, it's going to save me some heartache here to put that exponent in. So negative 12 times 4 gives me negative 48 as the exponent. And you do want to make sure for the exponent that you use the negative symbol on the bottom row of your graphing calculator and not the subtraction button. It does make a difference. So all right, use the negative button, that negative sign button in other words, on the bottom row. Because if you use the subtraction button by accident, it's going to say error on your calculator. And my example here does not specify how to round it. It will specify on the homework. Let's just say to the nearest dollar, because a lot of the homework questions say that as well. So we're going to round to the nearest dollar, and that gives us approximately, I'm going to go ahead and type it into the calculator. Typing into the calculator, I had 15,000, looking at what you wrote on the right side of the equal symbol there, times, we had parentheses, 0.08 divided by 12. Close the parentheses, division key for that main fraction bar. Remember, the brackets, you can just pretend those are ordinary parentheses. So I'm going to use the left parenthesis to represent the left bracket, 1 minus symbol, another left parenthesis, 1 plus 0.08 divided by 12. Close the inner parentheses. Got to hit the exponent button now. It's the up arrow above the division key. And here's where you have to use this negative symbol on the bottom row, not the subtraction button. So negative symbol for that exponent. Negative, we said 48 was our exponent. Hit your right arrow key, and then instead of a right bracket, just use a normal right parenthesis. Once you do several examples of this, and we are going to do several examples of this, it's not so bad. It's just a lot I know to type in. You might want to use the left and right arrow keys like I'm doing now just to skim to make sure you didn't forget anything. If you did forget something, you can always use the delete button. You can move your cursor. For example, I can move my cursor on top of that parenthesis, hit delete, and I can retype in something else. The insert button is second delete. It's INS. If you don't mind technology, feel free to play around with that a little bit. But once it looks good to go, hit enter. If we're rounding to the nearest dollar, because it's 0.1, it means we're going to round down, so I'm going to keep the 6 the same. So the monthly payment would be approximately $366. So jotting that down, approximately $366 was the monthly payment if you choose to go with loan A. Not done yet. It says now to find the total interest. So now we see why interest is a bad thing when we're borrowing money, when it's debt rather than savings. So let's think this out. To get the interest, first let's figure out how much we're going to end up paying when this loan is all said and done, because we're going to pay back a lot more than what we borrowed. This is how they make out by loaning us the money in the first place. They're charging us interest. So even though, for example, the car cost $15,000, when this is all said and done, we're going to pay a lot more back than $15,000. So thinking this out, our car payment would be $366. We just said our monthly payment would be. Times, this is a monthly payment, so we're making 12 of these a year, so times 12. So that represents how much we've paid in just 1 year, but this is a 4-year loan. So we're going to be doing this for 4 years, so times 4. And then that will give us the total amount we've paid, and we'll subtract what we borrowed. The $15,000 will give us the interest alone. So the formula I'm using to find the interest is I'm figuring out through multiplication the total amount we've paid, the full amount, and I'm subtracting the principal, the original amount we borrowed. So you could even think of it as I for interest equals A for full amount minus P for principal. It's just the full amount is taking a little bit of multiplication thought. So now when I do on my calculator, 366 times the 12 times the 4, by the end of this loan, even though the car cost $15,000, we'll have paid them back $17,568. So that's the full amount they'll have when this is all said and done, making that monthly payment, minus the $15,000 was the principal, the original amount we borrowed. So when I subtract the $15,000, we'll see that the interest that they charged us is $2,568. So interest for loan A, $2,568, doing the full amount minus the principal. Full amount will always be multiplication of 3 numbers. Your monthly payment times 12, because it's typically a monthly payment, times the number of years. Let's try one more of these, part B, same question, and then we'll hit part C on the next slide, which is still example 1 here, but it's comparing the numbers. So part B says, again, find the monthly payments and total interest, but now for loan B. So I'm only going to look at the loan B information. Starting with the monthly payment, I'll do this one in blue. We're going to use the formula that's at the top of the screen yet again. The principal comes first in the numerator. That's the amount we borrowed, which is still $15,000, times R. The interest rate is different in loan B. It's 10%, which as a decimal is 0.10, or you can write it as 0.1. Either way, you're moving the decimal point 2 hops to the left to get it to be a decimal. So 0.10 divided by N is still 12. Still making 12 payments per year. It's still a monthly payment. Divided by bracket 1 minus, parenthesis 1 plus, R over N again is 0.10 over 12. Close the parentheses. The exponent is negative. Negative N times T. N is still 12. Times the time frame for loan B is, this is a 6-year loan, so times 6. Before I type this whole thing into the calculator, I'm going to do the exponent, the negative 12 times the 6, which gives me 72. Negative 72, that is. So my exponent is negative 72. I'm going to go ahead and round to the nearest dollar yet again. Please keep in mind as we go through this that I'm just using that formula that was in black near the top of your screen. You'll still see this formula if you click on Question Help, View an Example while you're doing the homework. I know it has a lot of colorful circles going on right now, but that was the payment. Monthly payment for a car is P times R over N, divided by bracket 1 minus, left parenthesis 1 plus, R over N, close the parentheses to the negative NT power. So we have 15,000, parenthesis, 0.10 divided by 12, close the parenthesis, divided by, left parenthesis, button means left bracket, 1 minus, left parenthesis, 1 plus, R again was 0.10 divided by N is still 12. Close the parentheses, up arrow for exponent, negative sign on the bottom row for the exponent. We had negative 72 when we multiplied it all out. Don't forget to hit your right arrow key before you hit the right bracket. So that way your right bracket is back down on ground level. And rounding to the nearest dollar, because it's 0.8, the 7 in the 1 spot is going to round up to an 8, so about $278. So I'm going to go ahead and jot that down. So the monthly payment, if we go with loan B, is approximately $278. Now we got to find the interest that accrues, the total interest. Remember, interest equals the amount minus the principal. So the full amount we have paid back, well, our monthly payment with loan B, we just said, would be $278 times 12 times a year. We're making that payment. It's a monthly payment. Times, it was a 6-year loan, so we're doing that for 6 years. Minus the principal, the original amount we borrowed, was $15,000. So now let's multiply out in our calculator. 278 times 12 times 6. And wow, so even though we borrowed $15,000 for the car, with this option, since it's 6 years, we will have given them $20,016. So $20,016, I'm not going to be able to jot that number down because I'm running out of room here, but $20,016 is what you get when you multiply 278 times 12 times 6, subtract the $15,000, and you see that the interest alone is $5,016 you have given them. So they've charged you $5,016 that you have to pay back in addition to the $15,000 you borrowed if you go with loan B. Part C on the next slide is going to be still the same question. So this is still example 1, but now we're going to discuss these options. So part C says compare the monthly payments and total interest for the 2 loans. So let's just keep in mind, I'm going to write the numbers up at the top of the screen. So for loan A, we had said that the monthly payment would be approximately $366. And we said that the total interest we will have given to them was $2,568. And this was that 4-year loan where they charged us 8% interest at 8% interest. Now in blue, I'm going to write the information for loan B just to refresh our memories here. The monthly payment we calculated, I'll put PMT for payment since I'm running out of room, was approximately $278. And then the interest we calculated, because it was a lot longer of a loan, it was a 6-year loan, was $5,016. It was also higher because they charged us a higher interest rate as well. So this information, loan B, was for the 6-year loan, and the interest rate was a little bit higher. It was 10% interest. All right, so keeping those numbers in mind, now let's compare. And honestly, the loan that you would choose in everyday life just depends on your own financial situation. So you might be saying, when you look at the monthly payments, the monthly payment for loan A was $366, whereas it was a little bit lower for loan B. It was only $278. So the monthly payments were less for loan B. That was the longer term loan because it was 6 years rather than 4 years. I'll put in parentheses the longer hyphen term loan. I'm trying to use some of the terminology that the homework and like the view and example might phrase it as. Was a longer loan. So you're paying back on that car. You're making car payments for longer. However, even though you pay less per month, in the long run you end up paying out more because the interest was a lot more. So however, the interest in B was $5,016, whereas the total interest was only $2,568 in loan A. So however, you pay more for interest in loan B. Alright, so reading my chicken scratch handwriting here, monthly payments were less. The monthly payments were less for loan B, which was the longer term loan. However, you pay more for interest in loan B. So a financial advisor would probably say, if you have the means to afford either option, it would best benefit you to go with loan A, because even though you're paying more per month than loan B, you're paying way less in the long run in interest, and you would have paid off your car in only 4 years as opposed to paying 6 years on a car payment. However, that's not always affordable in everyday life. You know, we have all these other bills. So if you are in a situation where you don't have a lot of leeway, maybe you're living paycheck to paycheck, you might be stuck with going with loan B because it does have a smaller monthly payment. But the bad news for you then is you're going to be paying a lot more in interest in the long run, and you're going to be having to make car payments, unfortunately, for a lot longer. In addition to having us calculate the monthly car payment in this section, they'll also be asking you to calculate the cost of gasoline. So the annual gasoline expense, the annual fuel expense equals, you're going to take the annual miles driven and you're going to divide it by the miles per gallon that your car gets, and then you're going to multiply it by the average price per gallon. Now the units here are all annual, but honestly, in everyday life, you could convert all the units to monthly, for example, or even weekly. Whatever best fits the question you're asking yourself. Okay, so example 2 says, suppose that you drive 36,000 miles per year and that gas averages $3.50 per gallon. Part A, what will you save in annual fuel expenses by owning a hybrid car averaging 40 miles per gallon rather than an SUV that averages 15 miles per gallon? Round all computations to the nearest dollar. So we're only comparing just the gasoline expense here between the two cars. Let's start with the hybrid car, and then we'll calculate the savings. So this is going to be 3 steps. Step 1, the hybrid's annual fuel expense. So I'm writing hybrids. Whoop. Actually, let's write that a little bit nicer. Hybrids annual fuel expense equals, here we go. So on the right side of that formula on the top of your screen, first let's look up the annual miles driven. They said in the original question that was 36,000 miles per year. So 36,000 divided by the miles per gallon you get on that car. On the hybrid, we got, it says the hybrid car averages 40 miles per gallon. So divide by 40. Now we're going to times it by the average price per gallon for the year, which was $3.50. So times 350, I'm going to plug the whole thing into my calculator from left to right, make my calculator do the work. So 36,000 divided by 40 times 3.50. And I get $3,150 for step 1. Now we're going to go ahead and use the same formula for the SUV's annual fuel expense. I'll do that in red. This is step 2. SUVs. I'll just write SUVs equals, since I'm running out of room as usual. The annual miles driven is still 36,000. The only thing that's different is the miles per gallon. So divide by the miles per gallon that the SUV gets, which is only 15 miles per gallon, times the price per gallon is still $3.50. So I'm just going to do, again, the whole thing from left to right in the calculator. 36,000, you can probably hear my calculator buttons being clicked right now, divided by 15 times 3.50, enter. And whoa, a lot more, $8,400. So now, step 3, go back to the original question. I'll do this in blue pen. It says, what will you save? Meaning you're going to subtract the two numbers you got. So SUV, you'd be paying a lot more in gasoline, $8,400, minus the hybrid was $3,150. So $8,400 minus $3,150, and your savings are $5,250. Wow. So you'd save over $5,000 in just fuel alone if you went with the hybrid rather than the SUV. Now that's just one variable, of course. I mean, you would have to look into other expenses for the hybrid car and if that's suitable to your lifestyle. But it does go to show you, this question, that the car you pick and the miles per gallon it gets really makes a crucial difference in the overall cost that you're paying out for gasoline. So now part B, same question. If you deposit your monthly fuel savings, that was the $5,250 answer, by the way, we got in part A. If you deposit that money at the end of the month into an annuity that pays 7.25% compounded monthly, how much will you have saved at the end of the 7 years? Round all computations to the nearest dollar. So they want you to go a step further. They're saying, okay, buy a car that gets better miles per gallon, and then take that extra money that you were thinking of spending on the more expensive car, and instead of spending it on the more expensive car, put it into some sort of an investment where you're going to get interest back. And the formula, by the way, for that, I know it was a couple videos ago, that was the retirement plan annuity video, was the overall amount equals the deposit amount P, bracket parenthesis 1 plus R over N, raised to the NT power, that was the positive NT exponent, minus 1, close the bracket, all over parenthesis R over N. You might want to look at the formula sheet I've uploaded into your course, because you're welcome to print that out and use that on the test. So you don't have to memorize the formulas, just have to know how to use them, of course. And we're talking about at the end of a month, and it's compounded monthly. So we need to convert our savings to months. They're trying to trick us up here, because these were annual savings. So if I wanted to know just monthly savings, like this question is worded, I'm going to take the yearly savings of $5,250 and I'm going to divide by 12. So 5,250 divided by 12. So if I'm saving $5,250 per year, I'm saving $437.50 per month. It did say in the original question to round all computations to the nearest dollar, though. So because this is 0.5, I'm going to have to round up to approximately $438. So 438 is going to go into P. And actually, I'm going to move this formula up to the top of this slide so that I have room to write. Just jotting it down up here. There we go. Okay. Now I can erase this from here since I have it written at the top of the screen. Yeah, I gotta be really careful with the rounding. So again, the 0.5 means the 7 in the one spot rounds up to an 8. So that's approximately $438 you're saving per month. That's going to get plugged into the deposit amount P. So you're depositing that savings, that monthly savings into the account. So 438, plug it into P. Bracket, parenthesis, 1 plus R over N. Interest rate, 7.25%. Convert it to a pure decimal, meaning move the decimal 2 hops to the left, is 0.0725. All over, it's compounded monthly, so all the n's are 12. Raise it up to the n times t power, so that's 12 again for n, times the time in years. It's 7 years that it's sitting in the account, so 12 times 7. And don't forget the minus 1. Remember, I put this formula at the top of the screen is where I'm bringing this number down from. All over our parentheses R over N, so another 0.0725 over N is 12. Before I put this whole thing into the calculator though, as usual, let's take care of the exponent first. So I see a 12 times a 7 right here, which is 84. So 84 is actually our exponent. Typing this into the calculator, here we go. So 438, 2 left parentheses because the first represents the bracket, 1 plus 0.0725 divided by 12. Close the parentheses, up arrow for the exponent. 84 was the total exponent. Right arrow key brings your cursor back down to ground level. Minus the 1, close the bracket, meaning close the parenthesis, divided by, one more round of parentheses, 0.0725 divided by 12, close them up, enter. To the nearest dollar, 0.1 means we're going to round down, so keep the 6 the same. So that's $47,746. Whoa, you'd have a lot of money if you invested it. Writing that down, I think I can just barely squeeze it in with my big old handwriting here. So approximately $47,746. Now obviously the textbook, the publisher here of the My Math Lab is really trying to hammer in the point, invest, invest, invest. But please just be careful if you do decide to invest and look at the interest rate. I mean, they have an insanely high interest rate, which would be nice if all like savings plans and annuities had an interest rate of 7.25%. I know a lot of savings accounts have a very low interest rate, unfortunately. So if you are going to invest, please double, triple check what that interest rate is going to be so that you can make sure, of course, that you get a good plan.